Alright kids, time to train for the triathlon.
What triathlon?
Phase 1, kayaking. Phase 2, fishing. Phase 3, run 5 miles.
Let's go.
Phase 1, kayaking. Harriet, I forgot to tell you, there's a hole in your boat.
What?
For the cones, we are given the formula V equals 1/3 pi r squared h, where V is the volume, r is the radius, and h is the height. First, we will implicitly differentiate this formula and get the simplified version of dv over dt equals 1/3 pi r squared dh over dt plus 2/3 pi rh dr over dt. We are given the variables dh over dt, which is 0.7352 inches per second, and dr over dt, which is 0.4188 inches cubed per second. We will plug in these variables into the simplified version and get 403.778 inches cubed per second for the cones. For the cylinder, we are given V equals pi r squared h. When we implicitly differentiate that, we get dv over dt equals pi r squared dh over dt. When we plug in our given variable of dh over dt, we get 390.339 inches cubed per second. In order to find the total rate of change of the volume of the kayak, we will add up the rates of each section and then divide it by 2. We will then get 598.947 inches cubed per second.
Ow. The boat sunk. Phase 2, fishing. Hey, I caught a fish. It's pulling my leg.
In this equation, we are given the values for x and y, where x is the distance in which the line is cast, which is 15 feet, and y is the distance from the top of the pole to sea level, which is 9 feet. Then you would take these two values and plug them into Pythagoras' theorem to solve for the value of r, and x squared plus y squared equals r squared. We get the value for r, which is 17.4928 feet. Then we would implicitly differentiate Pythagoras' theorem to get 2x times dx dt plus 2y times dy dt equals 2r times dr dt. We would plug in the values solved from the prior equation to get 2 times 15 times 1.771 plus 2 times 9 times 0 equals 2 times 17.4928 times dr dt. Then you would divide both sides by 34.9857 to get dr dt equals 1.518 feet per second. To find the rate at which theta changes, we can set up the equation cosine theta equals x over r. X equals 15 and r equals 17.4928, which we solved for in part 1 of this problem. Then we can multiply both sides by r to get r cosine equals x. Then we would take the derivative of this equation to get r times negative sine theta times d theta over dt plus cosine theta times dr dt, which equals dx dt. Then we will plug in our values that we found in part 1 and the sine cosine values from the triangle to get negative 8.997 times d theta dt plus 1.301 equals 1.771. Then we would subtract 1.301 from both sides and then divide both sides by negative 8.997 to get d theta equals negative 0.0522 degrees per second or negative 2.61 over 5,000 radians per second.
I caught a fish.
Phase 3, run.
Do you hear that noise?
It's a raccoon.
To first find the surface area of the raccoon's stomach, we have to find dr dt. To do that, we have to use the volume formula of a sphere. We first implicitly differentiate this formula and get dv over dt equals 4 pi r squared dr dt. We then substitute the variables we know already, which are dv dt and r. Because dv dt is given to us in millimeters, we need to change our radius from centimeters into millimeters. We will then get 68.2 millimeters for the radius. When we plug in those values, we will get 2.974 millimeters cubed per second equals 4 pi times 68.2 millimeters squared times dr dt. Then we will get dr dt equals 5.088 times 10 to the negative 5th millimeters per second. We can then use dr dt to get dA over dt. We first need to use the formula of the surface area of a sphere, which is A equals 4 pi r squared. We then implicitly differentiate that formula to get dA over dt equals 8 pi r dr over dt. We can plug in our values that we already know and get dA over dt equals 8 pi times 68.2 millimeters times 5.088 times 10 to the negative 5th millimeters per second. We get the final answer of dA over dt equals 0.087 millimeters squared per second.
Okay guys, now it's time for the real triathlon.
What triathlon?